Hi, I'm going to be solving a differential equation by writing it in the form of an exact differential equation. An exact differential equation has the form m dx plus n dy equals 0, where m is the partial derivative of f with respect to x, and n is the partial derivative of f with respect to y. Differential equation can be put into the form of an exact differential equation using the integrating factor e to the my minus nx over n. The differential equation which I'm going to be solving is y times 3x plus y plus 3 dx plus 3x plus 2y dy. First, we identify our functions for m and n. Our m equals y times 3x plus y plus 3, and our n equals 3x plus 2y. Now we check to see if the differential equation is exact. This is done by taking the partial derivative with respect to y of m and the partial derivative with respect to x of n. So our my equals 3x plus 2y plus 3, and our nx equals 3. These are not equal, so we know that this differential equation is not in exact form. It can be put into exact form if there's a function my minus nx over n that is a function of a single variable, and then it can be put into this integrating factor. So if we take e to the integral of my minus nx over n dx, that gives us e to the integral of 3x plus 2y plus 3 minus 3 over 3x plus 2y dx. This equals e to the integral of 1 dx. Therefore, our integrating factor is e to the x. Now we can multiply e to the x by the differential equation to make it exact. So our new differential equation becomes e to the x times y times 3x plus y plus 3 dx plus e to the x times 3x plus 2y dy. Now we can check our my and our nx to see if they're equal. The new my equals 3 e to the x plus 3x e to the x plus 2y e to the x. And the new nx equals 3e to the x plus 3x e to the x plus 2y e to the x. So now our my and our nx are equal. So the differential equation is in exact form and we can solve it. To solve, we want to integrate either m or n. In this case, it's easier to integrate n with respect to y. So this gives us the integral of e to the x times 3x plus 2y dy. This can be rewritten by expanding the function to give us the integral of 3x e to the x plus 2y e to the x dy. We can now rewrite the integral by linearity to give us 3 times the integral of e to the x times x dy plus 2 times the integral of e to the x times y dy. Now solving each of these integrals will give us our function of xy. So the first integral equals 3 times e to the x times y. And our second integral equals 2 times e to the x times y squared over 2. And the 2's cancel, leaving e to the x times y squared. This is now our function for xy. So we can write f xy equals 3e to the x times y plus e to the x times y squared. The next thing we want to do is find the constant of integration, which we'll call h of x. The first step is to take the partial derivative of f(xy) with respect to x. This gives partial f with respect to x equals e to the x times 3xy plus 3e to the x times y plus e to the x times y squared plus h prime of x. We now want to solve for h prime of x. This can be done by setting our partial f with respect to x equal to our m. This gives us e to the x y times 3x plus y plus 3 plus h prime of x equals e to the x y times 3x plus y plus 3. Subtracting the right side from the left side, we find that h prime of x equals 0. We can now integrate h prime of x to give us h of x. The integral of 0 with respect to x equals c. We can now plug this into our equation for f(xy) to give us the final solution to the differential equation. That is 3 e to the x times xy plus e to the x y squared plus c. Simplifying, we get e to the x y times 3x plus y equals c. And this is the solution to our differential equation. Thank you.